What visions? You hopscotch humanity through our phases of evolution,
Right.
from where we are now, which seems somewhat primitive on a large cosmic scale.
Right.
And through this journey, you talk about our interface, our conscious interface with technology, including the world of computers, etc. Can you speak to that a little bit right now in terms of where you think we're going in the not too distant future in our interface with technology, and then we're going to go on from there?
Well, we physicists have asked about what civilization will look like 100, 1,000, 1,000,000 years beyond our technology. And when we look in outer space, we actually look for paradigms that we may see. We look for what are called type 1, type 2, and type 3 civilizations. We don't look for little green men. We look for the energy signature of planetary, stellar, and galactic civilizations.
Where are we in that mix right now?
Well, first of all, type 1 civilization is a planetary civilization. They control the weather. They control earthquakes, volcanoes, anything planetary they would control. Sooner or later, they exhaust the power of a planet. Hurricanes and tornadoes are child's play for them. And they eventually start to use the power of their star, not just to get a suntan, but to play with solar flares, to literally play with the entire star, to ignite stars, to play with stars like we play with coal or fire. Eventually, they exhaust the power of a star, and they become galactic. They begin to colonize huge sections of the galaxy, and they start to use black holes, for example, as their primary energy supply. Now, if you look at this scale, then you have to wonder, where are we? We are type 0. We get our energy from dead plants, oil and coal. However, with a calculator, you can calculate when we will advance to these various stages. If we simply grow at 3% a year, which is very modest economic growth, then energy consumption also grows at 3%. And we will hit type 1 in about 100 years. Now, you can already see the emergence of a type 1 civilization everywhere you go. When I open the newspaper, every single headline talks about the birth pang of a type 1 civilization being born right before our eyes.
What does that look like?
First of all, the internet. What is the internet? The internet is a type 1 telephone system. That's all it is. We are privileged to be alive to see the birth of a new planetary type 1 telephone system. The language of type 1 is already out there. Most elites already speak English. You can go anywhere on the planet Earth, scientific elite, business elite, cultural elite, and they all speak English. So we're already beginning to see a planetary language being formed. A planetary economy is also being formed. Look at the European Union. These nations have killed each other for the last 5,000 years, ever since the Ice Age ended. And why are they banding together to form the European Union? To oppose us. And who's us? We are NAFTA. Okay? So you see the emergence of a type 1 economy emerging.
And globalization and outsourcing is part of this.
A teeny-weeny part, just a small part. People react to globalization, but they don't realize it's much bigger than just globalization. We're also seeing the beginning of a type 1 culture. You can go anywhere on the planet Earth and show people 2 pictures of a man and a woman, instantly recognizable by anyone on the planet Earth. Madonna and Arnold Schwarzenegger. So you now know what type 1 culture looks like. It's going to be rock and roll, blue jeans, rap music, hip-hop, youth culture. That's going to be the currency, the language that this type 1 civilization is going to speak, going to enjoy. So we're already beginning to see the beginnings of a type 1 culture, entertainment, language, energy supply, politics, beginning of a language, and the beginning of a type 1 system. Now, we are type 0. So the transition between type 0 to type 1 is the most important transition in all of human civilization. Think about it. It's the most dangerous of all transitions because there are some people who don't want to be in type 1. They instinctively in their gut know that a type 1 system will be a system of different discourses, of different ideas and clashes of ideas and so on and so forth. And these people who don't want this transition are the terrorists. In their gut, the terrorists know that we're headed for type 1. They can't articulate it. They don't know the larger outlines of it. But in their gut, they don't like it. They would rather be in type -1. So, however, I believe that this transition from type 0 to type 1 is the most important transition in the history of human civilization. And we are privileged to be alive to see the beginning of this transition. Our children and our grandchildren will complete the greatest transition in the history of the human race.
Is this not inspired by absolute necessity because we can't live off of dead animals and dead plants and fossil fuels indefinitely? Is that kind of a
it's being forced upon us.
Yes.
In other words, some people say, let's try to stop the clock. Maybe we don't want to be part of a planetary civilization. It's too late. Look at the economies of the world. Like I said, the European Union is forming without anyone pushing them in that direction, because they know it's either the European Union for Europe or else they're going to be wiped out by competition from the United States, China, and India. And we already see the young people of the world yearning to get on the internet, yearning to find out what other young people are doing. Because young people instinctively know this is their future. They instinctively know, I want to be part of this future. And so I think the terrorists would like to prevent the transition, but I don't think they're going to. But it is going to be a rocky transition, because we do have nuclear weapons, we do have biotech technology, designer germs, and so it may not be a transition that's fully guaranteed. However, it's a very interesting transition because even filmmakers have been interested in this transition. Think of a movie that talks about the most scientifically realistic encounter with another intelligent life form in the universe. In this movie, we realize that Captain Kirk in the Enterprise is the most inefficient way to explore outer space. Hopping from planet to planet, there are 100 billion stars in our Milky Way galaxy. Perhaps half of those stars have planets. That's 50 million planets in our galaxy alone. The most efficient way for a Type 3 galactic civilization to explore their backyard is with von Neumann probes. Von Neumann probes are self-replicating machines. They're robots. They land on a moon because the moon is stable. There's no erosion. You can stay there for millions of years. And it makes a carbon copy of itself. And in fact, it makes a factory that makes millions of copies of itself. These robot probes then shoot out and land on other moons. Each one makes 1 million copies of itself on a moon and then shoots out 1 million more. So starting with one, you have 1 million probes landing on 1 million moons, and then you got 1 million million probes, and then 1 million 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 probes, until you have a sphere expanding at the speed of light containing these von Neumann probes. Now what do? They land on a moon and they simply wait. They wait for a Type 0 civilization to become Type 1. Type 0 is not so interesting. You have a lot of fights, a lot of wars, a lot of competing ideas and stuff. Type 1 is planetary. It's very civilized, very high level of science, very high level of an economy. And so the probe simply waits until the civilization makes a transition from Type 0 to Type 1. Now, where have we seen that before? We've all seen this before. This is the movie 2001. Because Stanley Kubrick, in the first 5 minutes of his film, interviewed all the top astronomers, cosmologists, and physicists and asked them a question. What is the most realistic encounter with a Type 3 civilization? And we laid it out. They would land on our moon. Our moon is stable, no erosion. They would then build factories waiting for a Type 0 civilization to become Type 1. And if you saw the movie, there's an instant where the astronaut touches the monolith and he goes like this because an alarm clock goes off. And the alarm clock signals back to the home race, we have come of age. Well, Kubrick and Arthur C. Clarke were off by 100 years. It's not going to be the year 2001. It's going to be 2101. In 100 years, we will be Type 1. We will have an operating moon base. How long will it take for us to get an operating moon base? 24-hour, 24/7 moon base? Another 100 years. And so I think we're right on schedule. So maybe on our moon, there's already, who knows, there's already perhaps a presence of an extraterrestrial visitation.
Well, there have been photographs and essays, and et cetera, written on the subject of having potential discoveries of structures already existing on the moon. How true might that be?
Yeah, well, you see, we have no operating moon base. We simply landed on the moon a few times, and therefore we don't know what kind of energy sources there are. We haven't scanned the moon. We don't really have a good picture of what's inside the moon or what probes may exist there. There could be a probe from a Type 3 galactic civilization sitting on the moon, and we'd never know it.
Right.
Plus, they may have nanotechnology. With nanotechnology, you don't have to have Captain Kirk and the Enterprise. They could be as big as a bread box. You could have miniaturized probes that are part organic, part DNA, and part silicon, a merger of carbon and silicon, in a device perhaps no bigger than a bread box, sitting on our moon, just waiting for us to make contact with it, waiting for us to become Type 1.
What about since we're on Hollywood, what about The Matrix? Now that really engaged an awful lot of minds, particularly those in their 20s and 30s. What is your experience with those kinds of potential realities, and how do you describe where that came from and what that's leading us to?
Well, there are two aspects of the Matrix. One is whether or not it's physically possible to have virtual reality indistinguishable from ordinary reality. And second of all, will the machines take over? Okay, so let's talk about them one at a time. Our most advanced robots have the collective wisdom of a retarded cockroach. Not an ordinary cockroach, a retarded, lobotomized cockroach.
So we're not in danger yet. Go ahead.
For my book Visions, I interviewed 150 of the world's top scientists. These are the directors of all the major scientific laboratories. These are Nobel laureates. I interviewed Rodney Brooks, who is the director of the MIT Artificial Intelligence Laboratory, the #1 laboratory in the world. And I asked him, well, how long will it take before our most advanced robots become as intelligent as us? And he said, well, first of all, our most advanced robot is on Mars. It's his godchild in some sense. It's the Mars rover. It's a real automaton. So I asked him, well, how intelligent is your grandchild, the Mars rover? And he said, well, a cockroach, a slow cockroach, a slow learning cockroach, okay? Now, a cockroach, on a table, you raise your hand, the cockroach scans your hand, says, danger, 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 runs into the cracks. I know, I used to live in a house with lots of cockroaches. However, the Mars rover, if you were to raise your tentacle to Mars rover on Mars, it would scan the tentacle and say, is that a dog? No, not a dog. Is that a giraffe? No, not a dog. 6 hours later, it would still be wondering, is that a cow? Meanwhile, the alien would have gone whack. It takes 6 hours for our most advanced robots to walk across the room. 6 hours for them to scan the room. The robot has to figure out where's up, where's down. Here is a rectangle. Is it a table, or is it a square, or is it a pie plate, or what is it? A robot would scan a cup, and it would understand all the triangles and circles and cylinders of a cup perfectly. It would see it better than us. But it would take hours for it to finally say, cup, cup. You know what I'm saying?
Yes.
Robots don't have common sense.
Right.
They don't know that water is wet. They don't know that mothers are older than their daughters. They don't know that animals do not like pain. They don't know that when you die, you don't come back the next day. They don't know that strings can pull, strings cannot push. They don't know that sticks can push but cannot pull. Robots don't know that.
So they're not poised to take over just yet.
Yeah.
But let's talk about a more realistic interface with technology, which is the interface between human consciousness and, say, nanotechnology in the world of computers. You talk about this a little bit in Visions.
Well, there is going to be a gradual merger of silicon and carbon in the future. Okay, it's already happening. People are already living with artificial parts in their body, and we love it. Because either that or else be paralyzed. Either that or else not have use of your arms and legs. So, and also DNA technology is getting to the point where it will eventually interface with silicon. Now, of course, this is far in the future. And I think that society has to democratically have a consensus as to how far to push this thing. Okay? So I think that is going to be one direction that we're going to go into. Another direction is pure silicon. Asimov wrote about the 3 laws of robotics to protect us against dangerous machines. Our most advanced robot has the intelligence of a cockroach. I suspect that in about 20 years, they'll probably be as intelligent as a dog or a cat. And perhaps in 30, 40 years, they'll probably be as intelligent as a monkey. At that point, they could get a little dangerous, because monkeys do have their own agenda. They have their own plans, their own goals, okay? Dogs and cats may not, but monkeys probably do. At that point, I think we have plenty of time to put a chip in their brain to shut them off if they have any murderous thoughts. So I think there's plenty of time. We don't have to say, you know, one day a robot will wake up and it'll be conscious and take over the world. It'll be decades of experimentation with cat-like, dog-like robots leading to monkey-like robots before we have to worry about them.
Let's jump now then from that to the subject of your latest book, Parallel Worlds, and talking about going from a concept of universe to multiverse. What does this mean? And what does it mean to be multi-dimensional? And how is this something that we can take into consideration in our lives now as we're struggling to go out of a 0 to a 1?
Well, right now we're rewriting all the textbooks in astronomy and cosmology. Cosmology has gone through 3 revolutions. The first revolution was initiated by Galileo, who turned the telescope to the sky and revealed for the first time the true splendor of the night sky. The second revolution was in the 1920s with the giant telescopes like Mount Wilson, where Edwin Hubble showed that the universe was expanding. So we have this picture that the universe is in some sense a soap bubble of some sort, and it's expanding and it's slowing down. And the soap bubble is made out of atoms, because everywhere we look we see atoms of hydrogen, helium, so on and so forth. Well, that picture we now know is wrong. Every single cosmology textbook on the Earth is being rewritten because we're now entering the 3rd era, satellites. Satellites have forced us to confront the fact that we may not be alone, that our universe may not be made out of atoms. So first of all, our satellites have shown that most of the universe is not made out of atoms. Every textbook is wrong. Every chemistry class is wrong. Your high school chemistry teacher was wrong in saying that everything's made out of atoms. We now know that most of the universe is made out of dark matter and dark energy. Dark matter makes up 23% of the universe. Dark energy makes up 73% of the universe. The stars make up 4% of the universe. And what about us, the higher elements? We make up 0.03% of the universe. We are by far the vast minority of the universe. The universe is not made out of atoms. And our soap bubble is not slowing down. It's speeding up. It's careening out of control. We now know that the universe is undergoing what is called de Sitter expansion. It's exponentially expanding. It's going to blow out. We could even see the end of the universe. And I'll talk about how the universe will eventually die. As I quote now from the great philosopher Woody Allen. Woody Allen once said, "Eternity is an awful long time, especially toward the end." Well, toward the end, it's not going to be pretty. The universe will freeze over in a big freeze. The last component of that picture of cosmology is also wrong. It's not just one soap bubble. We now believe there are other soap bubbles out there.
Soap bubbles that we perchance can't see because it's not part of the same 0.03% of what we are, right?
Well, our soap bubble, we're stuck to our soap bubble like flies on flypaper. We cannot leave our soap bubble. Gravity can go between soap bubbles, but we're stuck on our soap bubble. But we think that there are other soap bubbles. Now, they would be invisible because light only moves. Light is also trapped like flypaper, flies on flypaper. Light only goes on the surface of the soap bubble. So if there's another soap bubble right above you, you'd never know it. Now, where have you seen that before? That's in the famous novel, The Invisible Man. In The Invisible Man, H.G. Wells gives you a reason for being invisible. He says it flatly, the 4th dimension, hyperspace. H.G. Wells says that we live on a plane. We spend all our time thinking that our plane is everything there is. Well, just above us, there could be another plane. The invisible man is invisible because light passes right beneath him. Okay? Now, when I was growing up in San Francisco, I grew up visiting the Japanese tea garden. My mother would spend hours with me in the Japanese tea garden, and I would look at the carp swimming just beneath the lily pads. And I would spend hours looking at them. I would put my nose right up to the fish, and they couldn't see me. Their eyes would point to the side. Their universe was a 2-dimensional universe. And then I imagined, what would it be like to be a fish? And I said to myself, what a fantastic world. I could move forward, backward, left and right, but the concept of up made no sense. There is no world of up. Your eyes point to the side. The lily pads show you the end of the universe. There is no world of up. And so then I imagined a fish who was a scientist fish.
You must have been a trippy little kid.
Yeah, a little scientist kid swimming in the pond, and the scientist would say, "Bah, humbug. There's no world of up. There's only the pond. What you see is what there is. What you can measure is what there is. The pond is everything. The pond is all. There's nothing as the world of up." And so then one day I imagine reaching down and grabbing one of the fish, the scientist fish, lifting the scientist fish up into the world of up. What would he see? He would see beings moving without fins, a new law of physics. Beings breathing without water, a new law of biology. And then I would put the fish back in the pond, and what a story he would tell his friends. He disappeared from the universe and wound up in a world of up. Now today, we physicists believe that we are the fish. We spend all our time saying, "Bah, humbug. There's only the world that you could see and measure. There is forward, backward, left, right, up, down, and that's all there is. The universe is what we can measure." Well, our textbooks are now having to be rewritten. The WMAP satellite currently orbiting the Earth, its data is consistent with what is called inflation. Inflation was proposed by a good friend of mine, Alan Guth at MIT. He may win the Nobel Prize for this theory. Inflation says that the universe expanded in a hypercharged Big Bang, but it can happen again, and again, and again. And the soap bubble can fission in half and bud and sprout a baby soap bubble. Universes can have babies. Stephen Hawking calls them baby universes. And we believe that our universe may have come from a parent universe, and perhaps our universe also buds other universes. Now, what about the mathematics? What about the tests? Well, as I said, inflation fits all the data. It doesn't mean it's right, but it fits all the data. And inflation is based on the idea that it can happen again and again and again. But what about a theory of inflation? Well, that's where what I do for a living comes into the picture. What I work on for a living is something called string theory. I'm one of the pioneers in the subject. I'm the co-founder of string field theory, which is one of the main branches of string theory. Now, string theory says that it is the theory of everything. Einstein spent the last 30 years of his life chasing after an equation perhaps no more than 1 inch long that would allow him to read the mind of God. That was the ultimate goal, the holy grail of physics. An equation 1 inch long, just like E equals mc squared. E equals mc squared unlocked the secret of the stars. That's why stars twinkle. That's why our sun burns. That's why we have energy on the earth. Everything on the earth, all energy on the earth, ultimately comes from E equals mc squared.
But as one of your book titles would indicate, it's time to go beyond Einstein.
That's right. When we go beyond Einstein now, we now believe that string theory is perhaps a theory of everything. When we smash atoms, we find more particles, lots and lots of particles. So why should nature be so malicious as to give us thousands of subatomic particles? In fact, the situation was so bad that J. Robert Oppenheimer, the father of the atomic bomb, once said that the Nobel Prize in Physics should go to the physicist who does not discover a new particle this year. We're drowning in particles. When I got my PhD at Berkeley, I had to memorize all the names of these subatomic particles. Kappa mesons, lambda particle, pi mesons, tau mesons, hadrons, leptons. I couldn't get my PhD unless I, bosons and hadrons. I couldn't get my PhD unless I memorized all the names of all these particles. I hope that in the future, to get your PhD, a young graduate student will simply say, string. We think that a vibrating string has notes. Each note corresponds to a subatomic particle. If you can get a microscope and see into the electron, you would see a rubber band, and you kick the rubber band, and it vibrates in a different mode, becomes a neutrino. You twang it, and it becomes a quark. You twang it, it becomes a lepton. You twang it, it becomes a boson. Just a little string. So what are we? The subatomic particles are the notes on vibrating strings. What is physics? Physics is nothing but the laws of harmony you can write on strings. Well, then what is chemistry? Chemistry is nothing but the melodies you can play on vibrating strings. Well, what is the universe? The universe is a symphony of strings. And therefore, what is the mind of God? The mind of God in this picture is cosmic music resonating through 10, maybe 11 dimensional hyperspace. These strings are not ordinary strings. These strings force physical reality to be 11 dimensional.
What is the implication of, we're not just third dimensional, we've already heard from the invisible man scenario that we can recognize a fourth dimension. What does this mean to us?
This means that our universe is probably a soap bubble, a three-dimensional soap bubble, floating in 11-dimensional hyperspace. That if we were to leave our universe to go to another universe, we would have to take a detour through the 11th dimension. Now, I think that at one point when the universe dies, this may be our only salvation. People ask me the question, well, your unified field theory, the theory of everything, is it going to give me better color TV? Will I get better cable reception? What is it for numero uno? Okay. Well, I tell them that parts of the unified field theory do give you better color television. I mean, after all, where does color television come from? It comes from the unified field theory. Where does better, TV reception come from? From the unified field theory. But the ultimate use of the unified field theory is to one day leave our universe. You see, when a black hole forms, it's a hole, and everything falls into it. It's the ultimate roach motel. Stars fall in, they never fall out. But even kids ask their father, they say, Daddy, Daddy, if everything falls into a black hole, where does it go? Well, there's one theory that says that where it goes is to a white hole, at the other end of a black hole. So think of this soap bubble, sprouting a baby soap bubble. That's a black hole. Matter falls into the black hole and sprouts out the other end to create a white hole. Now, our universe is probably a white hole. How would you know a white hole if you looked at it? First of all, it would be expanding. Things would be rushing out. And it'd be very cool as it cooled. And by golly, doesn't that look like our universe? Our universe is probably a white hole. Now, in 6 years' time, we may be able to prove this theory. In 6 years' time, NASA is going to launch LISA into orbit. Laser Interferometry Space Antenna. It's the most advanced satellite system ever conceived of by the human mind. 3 satellites orbiting the sun, connected by laser beams. 3 million miles across, dwarfing the planet Earth. Think about this. A satellite system, a triangle, orbiting the sun, much, much bigger than the planet Earth. You can put the planet Earth as a dot inside this triangle. The shock wave from the Big Bang is still reverberating on a soap bubble. It'll detect gravity waves from the instant of creation. We're going to get baby pictures of the infant universe. A family album. Baby pictures. This satellite is so accurate that it should be able to see the umbilical cord. The umbilical cord, perhaps connecting our baby universe to perhaps a parent universe.
We're at the Science and Consciousness Conference. What is the implication of this in terms of our own awakening into it, our own individual expanded consciousness? Say individual, I mean interconnectedness as well, but what does this mean to us?
Several things. First of all, as I mentioned, only a type 3 civilization could fully utilize, that's the power of the Planck energy. The Planck energy is the energy of a type 3 civilization. A type 3 civilization would be able to open gateways, open baby universes, create a baby universe in a laboratory. They would have the power of a god. That's what this whole sequence is building up to. So when I talked about type 0, type 1, type 2, type 3, if we don't blow ourselves up in this whole process of evolving from a type 0 civilization, eventually we'll become masters of space and time. That's one aspect. The other aspect is more practical. That is, where do we fit into the larger scheme of things? This theory, string theory, is a quantum theory. In fact, it is the ultimate quantum theory. And all quantum theories say that everything vibrates. Everything is made out of a wave. And because of that, these waves intertangle with each other. This is called entanglement. And entanglement means that our waves entangle with waves on the other side of the galaxy. Instantly, in fact. We are all connected via this invisible web. Einstein at first didn't like this picture, because if you were to move in one part of the universe, the other part of the universe will also respond to you faster than the speed of light. Einstein at first didn't like it, but it's been shown in the laboratory. This is the famous EPR experiment. It's been shown many times now that entanglement does in fact make possible vibrations traveling faster than the speed of light. Now, of course, the information traveling at this faster than the speed of light is random information. You cannot send Morse code this way. You cannot send tomorrow's stock exchange this way. But what it does mean is that we are all entangled. Our wave functions all entangled with other wave functions. And I should also point out, in all fairness, there is one unfinished aspect of the foundation of the quantum theory. The quantum theory is the most successful theory of all time, even more accurate than Newton's laws of gravity. It works in the atomic realm. But it's based on a foundation of sand. There's the famous cat problem. The cat problem is the most profound paradox in the history of the universe. At the present time, no one has a solution for the cat problem.
What is that problem?
This is the famous Schrödinger cat problem. Schrödinger was one of the founders of the quantum theory, a theory that's been tested to 1 part in 10 billion. You can predict the power, the behavior of atoms to incredible accuracy. That's why we have transistors. That's why we have the internet. That's why we have laser beams, because of the quantum theory. However, the laser beam, transistors, the internet is based on a foundation of sand, because Nobel laureates still argue over the cat problem. Let's say I put a cat in a box, and the question is, the cat dead or alive? Well, you don't really know for sure until you look at the cat. Let's say the cat is connected to a gun, and the gun is connected to a Geiger counter, and the Geiger counter is connected to uranium. Well, to describe uranium, we have to write the wave function of uranium which is disintegrated and uranium which hasn't disintegrated. 50% chance maybe that it'll disintegrate, 50% chance that it hasn't disintegrated. That's the quantum theory. You work in probabilities, right? The atomic bomb is based on this theory. The atomic bomb wouldn't work if the quantum theory were wrong. But now hook the uranium to a gun. Well, is the cat dead or alive? Well, you have to add the wave function of a dead cat and add it to the wave function of a live cat simultaneously. So the cat is neither dead nor alive. Now you may say to yourself, well, that's stupid. How can a cat be both dead or alive? Well, the only way to tell is to open the box.
It's probability.
And then the cat then collapses into a dead cat or a live cat. Well, that means that observation determined existence. So you're now left with a very horrible, absolutely incredible paradox. Either the act of observation determines the existence of a cat, or the cat is simultaneously dead and alive. Both alternatives are mind-blowing. Both alternatives shake philosophy to the very core. Let's take the first alternative. Observation determines existence. But observation requires consciousness. Therefore, consciousness makes an observation, and then we see the cat is alive. Well, I determine the fact the cat is alive. Well, who determines me? Somebody has to look at me to determine that I'm alive and I'm not dead. Well, who determines him? Somebody has to look at him. And this is called Wigner's friend. Wigner was the winner of the Nobel Prize. He helped to build the atomic bomb. And this is called Wigner's friend. I have an infinite sequence of Wigner's friend. So who's the ultimate Wigner's friend? God. So starting with quantum theory, which is the most objective reductionist theory of all time, you go all the way up to God. Now let's say you don't want that. Let's say you don't believe in this Nobel Prize winner. Let's say you believe in the other theory. The other theory is even worse. The other theory is many worlds. Most Nobel laureates now are leaning toward the second. Steve Weinberg, winner of the Nobel Prize, has said the following. Imagine you're in a room and many radio frequencies are in the same room. Your radio is turned into one frequency, but you're very comfortable being in a room with many frequencies, right? But you tune into one. Well, these frequencies are now wave functions. In this room, there's the wave function of dinosaurs. In this room, because they never died 65 billion years ago, because a cosmic event prevented the extinction of the dinosaurs. In this room, there's the wave function of aliens, because perhaps aliens decided to colonize the Earth millions of years ago. In this room, there's the wave function of Alexander the Great. Perhaps he came all the way to the Americas instead of being just conquering most of the old world. Think about it. Your mind goes crazy. This is the multiverse. So welcome to the multiverse. We now believe that perhaps there are an infinite number of universes out there. Most of them probably dead universes. But some of them may be separated from our universe by a single quantum event. The smallest quantum event is a cosmic ray. Let's say a cosmic ray goes through Hitler's mother. Hitler's mother has a miscarriage. Hitler's never born. All of a sudden, perhaps 40, 50 million people didn't have to die, and they're living with us today. Or perhaps a cosmic ray went through Roosevelt's mother. And Roosevelt never roused the American people to oppose the forces of the Axis. And I'm speaking German today. And there's a swastika behind me right now. I mean, one quantum event separates us from these parallel worlds. Now, some people ask me the question, well, Professor, if Nobel laureates are even arguing about this, then the question is Elvis Presley still alive in one of these universes?
Many would say yes, but...
Well, believe it or not, there are physicists at Oxford University, David Deutsch, for example, who would say yes. There's a universe where the king is still alive.
Wow, kids, we've got some things to think about, and we're blown away if we think there's such a phenomenon as our dead Aunt Lily talking through a medium to us, and you're talking about many different potential realities.
Nobel laureates argue about this question. This is one of the greatest unresolved questions in all of physics. Physics is fantastic, it's incredibly accurate, but it's based on the cat. And at the present time, there's no consensus on the cat problem. There are hundreds of physics conferences. My friends attend these conferences. Physicists yell at each other, they scream at each other, because what is at stake is reality itself. The nature of existence, that is what is at stake.
Michio, thank you so much for taking time.
My pleasure.